Hi, so in this video we are going to discuss about supervised RNNs, and once again this is going to be a little bit descriptive video because we are going to look into a lot of concepts related to RNNs. So the first thing that we see is the basic architecture that we have of RNNs. We have input, then we have RNN block, and the good thing and the different thing about RNN block is that we have a self loop. Okay, so as soon as they process the data, they also kept that data for themselves, and then we have the output. So if we have to see a architecture of RNN for different time slots, it will look something like this. Suppose we are having data which is coming every second, and we are evaluating data after every 1 minute. Okay, after every 1 minute, and we start from t is equals to 0. So this will be the situation at t is equals to 0. Okay, at t is equals to 0, there was some data that came. Okay, it processed that data, it gave the output, but it also had a self loop, and the self loop actually transferred that data to t is equals to 1's computation. So at t is equals to 1's computation, we are having data from the we are having the new data, but we are also having the data from the previous computation that it had. Okay, and then it once again computes, and this data of t is equals to 1 and t is equals to 2 is transferred to the computation of data at t is equals to 2. T is equals to 0 I said here. So this data of t is equals to 1 and t is equals to 0 is transferred to the computation of t is equals to 2, and this keeps on happening infinitely. Basically this is a time series data, so it keeps on happening. Okay, so these are the computations at different timestamps. So this is how you can picture RNN working across different time slots. Now we have different types of input output pairs. Okay, so these are just like we had sets. So in sets we had different types of relationship. We had one-to-one relationship. By the way, this area is input, this is RNN, and this is output. Okay, so data is coming at one node, but it is being distributed across different nodes to create 3 different outputs. So one to many. Then we have many to one when we have many input but one data. This can be about our image. Okay, then we have many to many, and for many to many we have 2 types of structure. First we have this type of structure where every node have direct output, or other type of structure is that when we have a entire chain of processing before we generate any output. Some examples we can see. First is of this one to many. For one to many we can have example of image and its caption. Okay, so for example, image is passed and the system has to give the output of what describing the image basically. So it can say a dog catching a ball type of architecture. Then we have many to many, where we have text in English. Basically we are translating, so text in English become text in French. Okay, and length in many to many, it's not necessary that length is going to be the same. Okay, so length can be different. So here length is n, here length is n. And the third type of architecture that we have is many to one, where we have many inputs but one output. For example, sentiment analysis, the entire paragraph is analyzed to realize what is the emotion behind this paragraph. Okay, so let's see how RNNs work. RNN uses this concept of back propagation, but through time. So this is the type of back propagation that happens in RNN. The formulas that we use in RNNs are: we calculate this softmax, we calculate the ST as 10h is a function, by the way, and in this section we are not going to go in that details. Okay, so we are just looking at the overview of RNN and how they work in general. So these are the functions that we can use to evaluate the RNN working. All right, Okay, and this is how we can generate the output. All right. What are deep RNNs? Deep RNNs are the input of the next cell come from the output of the previous cell. So deep RNN are something like this, where we have multiple layers. Okay, we don't have just one layer, we have multiple layers, multiple hidden layers type of thing. Okay, so that is what we call as deep RNNs. Now till now we have discussed a lot about RNN. Now let's discuss one of the limitations of RNN. One of the limitations when we are using RNN in general. The limitation is this: long-term dependency. The RNNs are not able to deal with long-term dependencies very efficiently. And before we get any further, let's explain what is long-term dependency. Now imagine you are having you are typing something on your phone and you have some suggestion of words, right? Now when you are writing text like this, that the fish is swimming, you get very good suggestions like it is swimming in the pond, on sea, on aquarium. Okay, you get very good suggestions, and that means that RNN is actually identifying the context of your text. Okay, but the thing is, as we have seen, as we already said, the long term thing, but the thing is, when you're trying to process data or text which is of about 20 pages, 50 pages, a lot of pages are involved basically. So when the text is something like this, on the first page, suppose you write I was born in India. Okay, and then you keep on writing your entire text, and after 2-3 pages, if you write a sentence like this, I am fluent in, okay, then our systems are not able to predict the languages that are spoken in India. And honestly, if I speak, I feel like that we are expecting too much from our systems, because if we are having a lot of pages in between, even a lot of humans cannot cannot remember that information. But okay, since we are expecting things from machine, and machines are expected to do the things that humans cannot, so in a way, okay, so that is the thing. Okay, so suppose we have written a sentence in the first page, and after 2-3 pages we are expecting it to have it to remember the context of our information, that where I was born, and given the location where I was born, the system should know the languages that I should be speaking. Okay, so these are the long-term dependencies, and RNNs are not able to handle them well. Okay, so suppose this is the type of structure we are dealing with. Suppose for the first word we have this, second word we have this, third word we have this, and after so many words we are having this place where we need the context. So the output of so the processing of this node is not remembered till this node. All right, so this is because of the problem of vanishing gradients, and the longer the sequence, the smaller will be the value of gradient, and it will learn very slowly. So basically, when our sequence or data or what we are speaking, or lot of things becomes very huge, or the stock market analysis ke andar, if you are dealing with lot of range of prices, for example prices of last 20 years, so in those cases when the sequences are very long, the gradient becomes small and our model starts learning very slowly. This is the problem. Okay, now this problem happens with deep neural network as well. The networks that we studied earlier, like CNN or ANNs, but the thing is, the problem looks very pronounced when we are dealing with this RNN, because here we actually work on those long sequences. In CNNs and ANNs, we actually don't work in those huge sequences, hence the problem is not that visible. But since we are working on those sequences here, that is why the problem looks very pronounced. So the solution for this is long short term memory, LSTM. This is the solution to the problem of vanishing gradients. Okay, what is the solution? This is a very efficient solution to the problem of vanishing gradients. The alternate architecture that we can use instead of LSTM is graded recurrent unit. This is another thing that we can use, but for now we will just study the architecture of LSTM, and this is just an overview. Okay, this is nothing in much detail. So this is the architecture. First we have the cell state. Okay, then the data is actually passed through a LSTM memory cell. So LSTM memory cell, what it does, it forgets the irrelevant part. It selectively update the cell state values and output the certain parts of the cell state. Okay, and that is what the state of cell is at a time t. If you are making it look more better, then we can also say something like this, that we have hidden states like this, and basically the entire signal is passed through a memory cell, which helps our model to remember the long-term context. Okay, so this was all about RNNs, and with this we are done with our entire sessions or entire course. There is just a little thing that is left, a few points from one of my quizzes, and I'll just take them very quickly because I don't want to have another 1 minute video for that. Okay, the first thing is that RNNs are better than ANN as they are able to capture of the past input. Why? Because they have the self loop. Another thing is that GRU and LSTM can handle long-term dependencies and the problem of vanishing gradients. This is something we just discussed. And the third point is that RNNs, where RNNs can help us, they can help in weather forecast, they can help in categorizing the news article, they can help in classifying if the email is spam or not, and they can help in predicting the sentiment of a support ticket. So this was all about the course. Hope you learned something from this course, and I will see you soon with some more exciting content on education.